So what is ArcJet?
So ArcJet is a SDK that developers install into their application that helps them build in security. So we provide things like rate limiting, bot protection, email validation, and attack detection. And the idea is that you build it in as a developer into your code. You can define the rules in the code that it's actually protecting, and it will then give you the response back so you can change the logic of your application. And the idea is that developers can build this in from day one, or they can add it to an existing application, and you can kind of bootstrap these core features that build up the security profile of the application, just as you would with any other library that you might be using.
So I've said a lot on this podcast. I'm a front end developer and I really don't know too much about security. So ArcJet says it protects me from a lot of things, but like what are the sort of things it protects me from, like maybe in the context of Shield?
So Shield is our WAF-like component, and a WAF is a web application firewall where it analyzes every request and looks for suspicious activity. The typical thing that you might think about is a SQL injection or a cross-site scripting attack. The Shield component can detect that, but unlike every other WAF, it doesn't block it immediately. Most attacks don't succeed on the first request. Typically, when you're probing an application, you'll take a bit of time. You'll send requests to it. You'll see what it's doing, see how it responds. And then over time, you can figure out if there are any vulnerabilities, where they are. And that process of probing an application is what we detect. So this helps reduce the number of false positives, because the last thing you want is to have something you think is suspicious and actually you've just blocked someone who's trying to buy a product on a website or sign up to your service. And so we use the profile of the requests over a period of time to decide whether we think a request is suspicious. And then we return the result back to you. And as a developer, you can just accept that result and it might just be block the request. But more often, you probably want to take some kind of custom action. So if the user's already authenticated, it might be that it's flagged as suspicious and you decide, oh, well, let's ask them to re authenticate. Can they prove who they are? Or you might be wanting to protect your API from abuse, large numbers of requests coming through. If it's an anonymous user, then you want to apply a certain rate limit. But if it's your largest paying customer, then you probably don't want to block them. You might just want to trigger an alert to your team so they can reach out and say, what are you doing with the API? Can we help you change your design? Or do you want to pay us more for a higher quota or something like that? And the idea with that, Jay, is you can make those very granular decisions because we have the context of the request, you have the context of where it is in your application, who's authenticated, what's the session, what do you want to do as a developer, rather than it being something that's generic and sits on the network, which has no understanding of your application, of your tech stack, of what you're building, and will just issue block requests without you even knowing what's going on.
Um, I want to talk about the approach that you're taking here a little bit because it is a little bit different than kind of what I've seen in the past. So you'd mentioned earlier ArcJet is an SDK. So you've got a lot of really great examples on your landing page of like integration into Node.js or Next.js or a bunch of different frameworks and tools. And you sort of like call the ArcJet SDK, you set it up, give it a key and some rules that you want to configure. And then based on what you're doing, if you're doing Shield, you might have it in some middleware that's like handling the request and kind of looking at that. Or if it's doing bot detection, it might do something a little bit different. If it's doing, email detection, then you'll pass emails to it manually. But the thing that's interesting about this approach is that in some middleware, you're making a request to ArcJet to do this verification. And this has some really interesting trade-offs. And I'd like to talk sort of like in depth about like what those trade-offs are, what this makes easy and like what this might make harder. So do you kind of want to start it off from there?
Right. So we come at this from the perspective of a developer who is probably trying to solve a problem rather than thinking about security specifically. So the common example I use is they're getting spam signups. To solve that problem, you need to do rate limiting because you want to just make sure that like normal people will submit a form once or twice. If they make an error, maybe 3 times in a short period of time, not hundreds of times and not even tens of times. So you have to sort out rate limiting. So probably if you've got Redis in there or figuring out where you're going to store the rate limit because you need to track that across time. So you have to build something there. And then you probably need to do bot detection because you want to detect those automated clients. And to do bot detection, you're going to have to figure out a product to buy. There's probably a commercial product that does that. And then you need to do email validation and verification. So you need to make sure the email is actually a valid email string. But you also want to do things like, well, is this email address actually deliverable? Does it have MX records? Where is that user signing up from? Are they going through a proxy? Are they going through Tor? Is it coming from a cloud IP address, which might be suspicious? And so to do that, you probably got to build that as well. You got to write some code. And so you've got these things where you've got to figure out Redis, which is easy on a single server, but becomes more difficult when you're deploying it globally. You've got to integrate an existing product, and then you've got to build something. And all of that is undifferentiated as a small startup in particular, but any business really. And developers generally prioritize fixing bugs and building features for users. Building this kind of security functionality doesn't differentiate them, but it's a pain point because it might be costing them money or it might be hurting their credit card processor reputation or something like that. And so we come at this from the perspective of the developer trying to solve the problem, which we want to be as quick and easy as possible. And the way that developers normally do that is they install a dependency, install a library to help them solve that particular problem. And they also don't want to then have to manage infrastructure. So Redis, it's not that difficult to manage on a single server, but it gets more complicated. If you're using a database, then that's more challenging. You're probably already using it, but is it set up to do rate limiting? Is that the right place to store rate limiting? How do you design all that kind of thing? And so the way most security products do it is by having an agent, which you've got to install somewhere, or by putting it at the network. And our philosophy is we don't want an agent because it's another thing for the developer to manage. If they're in a larger company, it's probably another team that they've got to get approved or managed somewhere. It's probably yet another agent that they've installed on their servers. And we don't want to have to give them anything else to manage. But also we want developers to be able to do things locally. You can't put a network firewall and run it locally on your development environment. And the idea is there that you can write the security functionality, you can integrate ArcJet locally, you can test it locally. And then when you push it to staging, it's the exact same thing that's running there. You can run it in CI and test it, and it's the same as when you go into production. The number of people I've met who have kind of got a new security product, it's only in production, they turn it on, and then suddenly everything breaks because it's changed something in the environment or is filtering something. And the idea with ArcJet is you can avoid that pain of breaking production by testing it locally. One of the big challenges that we saw was that, well, in serverless environments, there's no shared state. And so the reason you have something like Redis running somewhere else is because you need to store something. You're tracking the rate limit. You need to store that somewhere. And so the natural place is to put it in Redis. Because when you're using a service environment, the function is going to recycle on sometimes every request. More likely, it'll stay warm for a little bit, and then it'll shut down, and then you'll have the cold start. And then you've got to distribute it globally, depending on your application. And so this was a real challenge because we wanted to have no agent, no infrastructure, but we also needed to do things like tracking state across requests. And so the architecture that we came up with is the SDK is a very lightweight wrapper around a WebAssembly module. And that does a lot of analysis. It runs locally in your environment. And we can do things like bot detection. We can do the email validation entirely locally. That just runs as part of the node process or the Python process or whatever it is that starts up. But then when you configure a rule that requires tracking state across multiple requests, or needs to do something like a network call to do an MX record lookup, which might be blocked on your firewall or might be really slow, then we have our API. And so we've got this real-time decision API that ArcJet's SDK will send the request to, get a decision, and then return that back to the SDK. And we run that API in every AWS region as close as possible to your application. We're also deployed on fly.io, so we're deployed in every single one of their regions. And the goal is that we are 1 to 2 milliseconds of network latency to our API. And then we give ourselves an SLA of 20 milliseconds to give you a decision, full round trip, including the network. So it adds a bit of overhead, but not very much, 10 to 20 milliseconds. And that's when it needs to make a request to the API. And it has this decision logic built in so that it doesn't always have to go to the API if we can do it with the WebAssembly. But then if we return a deny decision, that gets cached. And so there's this complicated logic that determines whether it goes to the API, what it's in memory, what it caches, and whether we can use that WebAssembly component.